Hi, my name is Kolam Rasul. I am your TA for mechanical engineering course 211 fluid mechanics. Um, Today I'm going to explain the question and answer session. So in this session, basically we will try to understand and solve some of the problems. Now, let's start with this one. This one is problem number 3.69, right? So in this problem, it says that determine the flow rate through the pipe. So basically, this is a pipe, right? This is a pipe, and you have water flowing through this pipe. You also have another fluid inside this tube. You see that the water, its density is rho, but these different fluids density is 900. Rho A equals to 900 kg per meter cube. Now you know that for water its density is 1000 kilogram per meter cube, or sometimes people use 998 or 999. So in this solution they use 999 kilogram per meter cube. That's the density of water. Now, in this problem, you see that the water is flowing from left to right, and they also have a tube here placed here. And if we consider point 1 and point 2, um, uh, we need to determine the flow rate through the pipe, right? So to determine the flow rate through the pipe, we need the velocity. If we know the velocity, we have the radius or diameter, so we can calculate the flow rate, which is Q, right? Basically, the Q flow rate equals to A1 P1. A1 is the cross-sectional area, and P1 is the velocity. So area we know, right? Pi by 4 d square. That's the area. Now we know the d. However, we don't know the v, right? So v we need to calculate. So which point we need to calculate the v? We should be at any point like this, not in this point, right? Because in this point you have a barrier. So you can calculate the v at any other point. So let's assume that, consider point 1 and point 2. Now, if we apply the conservative law between point 1 and point 2, we can have this one. P1 divided by rho plus P1 square, this point, at this point, divided by 2z plus z1 equals to for the P2, I mean the position at P2, 2. So P2 divided by rho plus v2 square by 2z plus z2. Now, point 1 and point 2 are in same elevation. So that is z1 equals to z2. So z1 and z2 cancels out, right? And for v2.2, you see that the because of this tube position, there is no any velocity in this point. So the v2 is equals to 0. Now, we still need to calculate the P1 and P2 value, right? That is the pressure at point 1 and point 2. How can we calculate? So we need to use another equation. But if we modify this equation, apply this Z1 equals to Z2 and V2, so we'll get this equation, P1 by rho plus V1 square by 2Z equals to P2 by rho. ZZ cancel out. And V2 square equals to 0. So V1 equals to root over 2Z into P2 minus P1 divided by rho. Now P2 minus P1 difference, that's what we need to now calculate. We can calculate this P2 minus P1 using this equation. If we apply this equation for point 1 and point 2, we'll have P1 minus rho L. L is basically this distance, and this distance is the h, right? So rho L minus rho M into h plus rho into L plus h, that is L plus h equals to P2. So you can get P2 minus P1 equals to rho minus rho M. Rho is the density of water, and rho m is the density of this fluid, right, into 8. So if we put this value P2 minus P1 in this equation, we'll get V1 equals to root of R2Z into 1 minus rho m by rho into 8. Now we have the Z, it's constant, rho m, it's 900, and rho is 999. That's the density of water multiplied by 8. H is this value, 2.5 meter, 2.5. If you put this value, you'll get the value 2.2 meter per second. That's the velocity of water in position 1. So it's actually the same in all other positions. So if you now put this value V1 in this equation, you'll get 0.0111 meter cube per second. So that's the flow rate of water through this pipe, and that's what is required or is asked in the equation, question, determine the flow rate through the pipe. So this is for question number, problem number 3.69.